All right, hi everybody who's tuning in, and anybody who's watching this a bit later. Welcome back to our lesson on lesson 8 today. We're going to continue on and do a few more things with some rational functions. So we're going to take a look at a couple of things today, mainly doing some simplification with rational functions, and then also doing some arithmetic. So just to kind of start off, let's take a look at something like this. And let's say that we want to try to simplify this rational function as much as possible. Typically what we're going to have to do is we're going to have to try to factor this thing out. So the factoring is not really going away from the last couple of lessons. We're going to have to keep that up. So what we want to do is take a look at this bottom part, the denominator. Let's see, two things that multiply to get 6 and add up to be -5. We can factor this into x minus 2 and x minus 3. The idea here is that we're hoping that we can divide some things out, some common factors out, to simplify this down a bit more. If you really want to think about what we're doing, it's really the same thing we do when we have just regular fractions. So imagine you had something like this, 5 over 10. Well, we know that we can factor out the 10. We can split that up. We can do 5, and then 10 will become 2 times 5. And the idea is that now we can divide out the 5s. If you want to think about why this works, is you can actually think of 5 as like 1 times 5. And then when you break this up, it's really 1 over 2 times 5 over 5. And then 5 over 5 just divides out to be 1. The shortcut that we usually do is we just kind of divide it out right here, and we go to 1/2. But of course, you can split it up like that. That's why it works. It's not magic or anything like that. And the trick is that this division, this simplification like that, only works whenever the things are separated by multiplication. I'll show you an example of some common mistakes later, but they have to be separated by multiplication. So up here, we see that we have the x minus 3 in the top and an x minus 3 in the bottom. And what we're allowed to do in that case, since this is separated by multiplication, and you could also kind of think of this as like 1 times x minus 3 if you really want to. Actually, that's pretty good to think about that. Because the x minus 3 is in the top and the bottom, and this is separated by multiplication, they'll actually divide out to get 1. So what will be left over with in the numerator is going to be a 1, and then in the bottom we're going to get x minus 2. If you're curious why we might do something like this, this is maybe a little more advanced, but you can kind of start thinking about it. The graph of x minus 2 looks something like, this. And the difference between this graph and this graph is that this graph also has a 3 that's excluded in the domain, because 3 will make the denominator equal to 0. But actually, the fact that the 3 makes the denominator and the numerator equal to 0 tells us that there's actually going to be like a hole in this graph. Oops. So there's actually another number that's excluded from the domain that is not actually a vertical asymptote. If you take the next algebra class up, college algebra, we'll talk a little more about that. But if you're kind of curious what the difference between this function is, if they're actually equal to each other, that's actually the difference. So there is a slight difference if you went to graph that function. But in terms of our simplification, this is good enough for us just to get it down to this. All right, let's try maybe one or two more of these, and then we'll do a little bit of arithmetic. All right, we could also have something like this, x squared minus 36 over x plus 6. Now you have to remember your factoring rules here. Factoring rules, this would be a difference of two squares. So in this case, the square is going to be 36, so 6 times 6 is 36. So we know this is going to factor into x plus 6, x minus 6. You could also use the other way of thinking about it, what two numbers multiply to get negative 36, but when they add, they get 0, because there's a 0x here. So it'd be positive 6 and negative 6. And then, of course, the x plus 6 is still in the denominator. And again, I could think about this as x plus 6. I could think about this as 1 times x plus 6. And then this x plus 6 and this x plus 6 will divide. to 1. The reason I like to think about there being a 1 down here is because a lot of times students will, I don't know, they do funny things. Sometimes they'll think it's a 0 or something like that. So it's just good to remember that that's just going to be a 1 left over. So then you get x minus 6 divided by 1. That's just x minus 6. So that's kind of our general strategy here for taking care of these functions, is that we're going to try to just factor what we can in the numerator and the denominator, and then we're going to try to see what we'll divide out. All right, maybe one more quick one. How about something like 5x squared? This is actually one from the practice problems in the book. 5x squared over 5x minus 20. Again, let's try to factor this. The bottom factors pretty nicely, just the greatest common factor. So this would be 5 times x minus 4. The top, I'm going to pull the greatest common factor of 5 out here as well. So that's going to be 16. And now this one will continue to factor as a difference of two squares. So 5 times x plus 4, x minus 4, like that. And then all of that over 5 times x minus 4. Again, if you're having trouble remembering some of these factoring rules, go back and make sure that you practice those a bit, because they're gonna be out all throughout this lesson, and also kind of continue on for the next exam. All right, so in this case, a 5 can divide out, and then also an x minus 4 and an x minus 4. So I'm going to be left with just x plus 4 in the numerator, and the denominator I'm just going to be left with 1. All right, so just x plus 4 over 1, that's just going to be x plus 4. So these are not too bad if you remember your factoring rules. If you don't remember the factoring rules, they can be a bit tricky, because that's basically the hardest part of these. All right, let's try some arithmetic now. You're going to find with the arithmetic, multiplication, division are going to be really easy. Addition and subtraction are going to be a bit harder. So let's actually start with some multiplication and division. So let's say I'll pull one out of the practice problems. How about this one? We've got two functions. Let's say this one is f and this one is g. All right, so let's start off doing some multiplication. So I want to do f of x times g of x. Now, if you remember your fraction multiplication is very nice. So think about something like this, 1 over 2 times 3 over 5. Well, when you do fraction multiplication, you don't need common denominators, anything like that. You can literally just multiply straight across. So in the numerator, you're going to get 1 times 3, which is 3. In the denominator, you're going to get 2 times 5, which is 10. So that one just comes out to be 3 over 10. So multiplication is generally pretty nice whenever we're dealing with fractions. So the same thing is going to happen here. If I'm multiplying 5 over x plus 1 times 5 over x, then I don't have to do anything special. I just have to go straight across and multiply. So 5 times 5 is going to be 25. You have to be a little bit careful here, because when you multiply this times x, you actually have to multiply x plus 1 times x, so that whole thing gets multiplied times x. So I would actually write it out like this to start. 25 over x times x plus 1. This is actually probably totally fine just to leave it like this, because now the numerator is factored, or sorry, the denominator is factored. It's always nice when things are already factored. If you wanted to, you could multiply it out, and there might be some situations where we do need to multiply it out to continue to simplify, but either one of these answers is totally cool. No problems there. And then you just want to look and see if anything is going to simplify. This one's all the way factored. This is all the way factored, so nothing's going to divide out like before. All right, so let's switch that over to division. Division's also not too bad. So let's do f of x divided by g of x. All right, now in this case, you have to remember your division rules for fractions. If we have something like 1/5 divided by 2/3, well, what's the rule? Well, the rule is that you take the reciprocal of the second fraction, and then you multiply it times the first fraction. So we literally just reverse this one by doing the reciprocal. So this 2 over 3 becomes 3 over 2, and now we're going to multiply them together. And now 1 times 3 is 3, 5 times 2 is 10. Same thing is going to work when we're dealing with these expressions. So to divide this, I'm just going to do 5 over x plus 1, and now instead of dividing by 5 over x, I'm going to multiply by x over 5. Okay, and when I multiply this out, I'm going to get 5 times x in the top, and then again, you have to think about 5 times this entire thing, so it's 5 times x plus 1 in parentheses. You probably know the common mistake is going to be to do 5x plus 1. That's not correct. It's 5x plus 5, or you can just leave it factored. The reason it's nice just to go ahead and leave it factored here is because if you notice, this is 5 times x and this is 5 times x plus 1. Now the 5s are actually just going to divide themselves out. And we get a little bit of a simplification here. So x over x plus 1, that's going to be my final answer. Now be very careful here. As you can guess, a lot of students, when they see x over x plus 1, what they want to do is they want to do something like this and divide out the x's. That's like algebra mistake number 1. See it all the time. You can't do that. If you want to see like a proof of kind of why that's not allowed, you can do something really simple. You know, if that were allowed, then you should be able to do something like this and then divide out the 2's. But we know this should be 2 over 3. That's definitely true. But if you did something like that, you would get 1 over 1 plus 1, which is 1 over 2, which is not equal to 2/3. So that tells you that this is bogus. So just be really careful with that. The only time you can divide out is if things are separated by multiplication. This is this is separated by addition. So that's no good. You have to be very, very careful. All right, so multiplication, division, not too bad. Let's do some addition and subtraction. This is where it's going to cause people some problems. So let's do f of x plus g of x. So I'm going to do 5 over x plus 1 plus 5 over x. All right, so what's the problem with addition when it comes to fractions? Well, again, think back to regular old fractions with numbers. If you try to add 1/2 plus 1/3, you're not allowed to do this until you get both of these guys to have the same denominator. They have to have a common denominator. In this case, 6 is the least common denominator. So what I need to do is I go back and I multiply this by 3 over 3, because I know that 3 times 2 is 6, and I multiply this one by 2 over 2, because again 3 times 2 is 6. And that's going to get me 3 over 6 plus 2 over 6. All right, then from here you have to remember your addition rules. The addition rules say that you add the tops, so 3 plus 2, so that's going to give you 5. You add the numerators, and then the denominator is going to stay the same. So this will just stay a 6. So 3 over 6 plus 2 over 6 is 3 plus 2, all of that over 6. So the denominator stays the same, and the numerator, you add them or subtract them. The same rule works for subtraction. So if that works for numbers, it should also work for these expressions. So the tricky thing is, how do you find that common denominator, because it's not numbers anymore? Well, think back how you can always find a common denominator for fractions. Let's say that you did not know that 15 was the least common denominator for this fraction, for these two fractions. Well, what could you do? Well, you know that you can always just multiply the two denominators together, and that's going to definitely give you a common denominator. Okay. Sorry, I'm trying to keep this microphone from bouncing against my chest. I know it makes a little thumping sound when I do that. All right, so what would you do? Well, you know that you could do 5 times 3, and that will definitely be a common denominator. It might not be the least common denominator, but we really don't care about that as long as we get a common denominator. That's going to allow us to add the fractions. So you can do the same thing here. If you want to get a common denominator for these two denominators, x and x plus 1, you could always just go over here and say, well, what if we just multiplied them together? That would be a common denominator for these two, the same way we did with the numbers. So what we can do is we can literally just multiply these together. Well, how are we going to change the fraction? Well, you want to multiply this one by x, okay? But remember, with fractions, anytime you multiply the bottom by something, you have to also multiply the top by the same thing. So I also have to multiply the top times x. So this is going to get me x plus 1 times x in this denominator. That's cool. Now I need to get x plus 1 times x in this denominator. Well, what do? Well, I can multiply this times x plus 1. But again, if I do it to the bottom, I also have to do it to the top. So this really is going to become 5x over x times x plus 1 plus 5 times x plus 1 over x times x plus 1. Now I've got two fractions. They have common denominators, so I'm good to go in that regard. That means I can add the numerators, leave the denominator the same. Now I'm just going to go ahead here and distribute out the 5. So this will be 5x plus 5, just to save us a little work. And now when I add these, I'm going to get 5x plus 5x, that's 10x, and then plus 5, so that's 10x over 5, and then the denominator, I'm just going to get x times x plus 1. Now technically I probably should go ahead and try to factor this if I can. There is a greatest common factor here. I can factor a 5 out, and that'll leave me with 2x plus 1. I want to do that just to see, just in case something else would divide out. Like if this had been x plus 1, this x plus 1, this x plus 1 would divide. It's 2x plus 1, so they're not exactly the same, so I can't do any division. But it's nice to have things in factored form because it's just nice to make sure that there's no simplification that could be done. So that looks like a really good answer to me. Doesn't look like anything else could be simplified. So you can see with the addition there's a little more work, but it's actually not that bad. You just have to think a little bit. All right, so what about subtraction? Like what if I change this guy to subtraction? Well, the nice thing about subtraction is the process is going to be exactly the same. You still have to go through and get the common denominator. So actually when I do the subtraction, the only thing that changes is this operation right here, because I would actually have gone through to do the exact same operation to get the x times x plus 1, x times x plus 1. So I don't have to redo it again. I can just do it with subtraction. The only thing I have to be careful about now is when I'm subtracting, I have to subtract this entire numerator. Well, who cares, right? Well, the reason that's important is because the negative is going to distribute to the 5 as well, not just the 5x, but the 5. So what's going to happen is we're going to get 5x minus 5x, and then this negative 1 distributes to the 5, and then we're going to get a minus 5 there instead of a plus 5. And then the denominator is going to stay the same. So now I'm going to end up with 0x minus 5, so just negative 5 over x times x plus 1. And as you can imagine, a really common mistake is to not distribute that negative sign, and that of course is going to lead you to the wrong answer, so be very careful with that. Alright, let's try another one. I think I'll pull another one from the practice problems in the book. How about... Alright, so how about the last practice problem? Let's do f of x is x over x plus 1, and then g of x is 2 over x minus 2. All right, if you see me looking back, I'm just making sure that everything's going fine through the live stream. All right, let's start with multiplication because that's the nicest one. So let's do f of x times g of x. Okay, so this is going to be x over x plus 1 times 2 over x minus 2. Again, I don't need common denominators for multiplication, so this is really nice. I don't have to do anything special before I can multiply these. So I can literally just multiply straight across. X times 2 is 2x. And then x plus 1 times x minus 2, again, be careful. You just want to go ahead and put both of these in parentheses. And then write it like that, x plus 1 times x minus 2. You could multiply these out. In this case, there's not really a reason to, because I know nothing's going to factor out up here because there's no other terms. So I'm just going to leave it factored. That's good enough for me. If you wanted to, you could write it as, x squared minus x minus 2, but I don't really see a reason to do that in this case. I'm just going to leave it factored. So that looks great. All right, what if we did division? X over x plus 1 divided by 2 over x minus 2. Remember, if you do division, then you're really doing multiplication with the reciprocal. All right, so we're just going to take the second fraction, and we're going to take the reciprocal over it, and now we multiply. X times x minus 2, again, make sure you're thinking about this thing in parentheses, and you're thinking about this in parentheses. So when I write this, it becomes x times quantity x minus 2. This is going to be 2 times quantity x plus 1. You can see where it's easy to make a mistake if you don't put that in parentheses. If you ever have anything that's bigger than a monomial, if you have a binomial bigger, just go ahead and put it in parentheses, and then it'll help you keep you from making a mistake. Again, I could multiply this out, but it's already factored, so why would I want to undo factoring? Factoring is not easy. So I could always multiply it out later if I wanted to. And actually, since it's in factored form, I can see does anything like divide out to simplify. In this case, nothing's going to divide out. So this looks like a good answer to me. Okay. All right, let's do some, let's start with subtraction this time since we did addition first last time. Just to make sure everybody's good with that. All right, so let's do x over x plus 1 minus 2 over x minus 2. Now again, I have to have common denominators. This denominator is x plus 1, this denominator is x minus 2. So if you want to get a common denominator, what we can do is just go over here and multiply them together. And say this would be a perfectly good common denominator if you multiply those two denominators together. All right, so let's do that. What would I need to multiply x plus 1 by to get x minus 2? Or sorry, to get x plus 1 times x minus 2? Well, I need to multiply it times x minus 2. Whatever I do in the top, whatever I do in the bottom, I'll also do in the top. Over here, I need an x plus 1. Again, put these in parentheses. And then whatever you do to the bottom, do to the top. And then put these in parentheses since they're bigger than a monomial. All right, so that's kind of our first step. So up here I'm going to get x times x minus 2 over x minus 2 times x plus 1 minus 2 times x plus 1 over x minus 2 times x plus 1. Now in this case, I do need to go ahead and multiply this out. Why? Not in the bottom, but in the top, in the numerator. Well, if I look ahead, I should see that some things are going to combine. For example, if I multiply this x out, I'm going to x squared minus 2x. And then over here, I'm going to also get a 2x and a 2. So I'm going to have a couple of common terms, of like terms that I think can combine, and then maybe whatever I'm left over with it might be factorable as a factorable quadratic. So in this case, I actually am going to go ahead and multiply out the x. So this will be x squared minus 2x. And the same thing right here, 2x plus 2. Just so that I can combine these, and then maybe it'll be factorable as a single quadratic. All right, so again, be really careful here. When you subtract this, you have to subtract that entire thing. So in the numerator, I'm going to get x squared minus 2x, and then minus 2x, and not plus 2, but minus 2. And then the denominator is going to stay the same. Hopefully that's clear. Okay, then x squared minus 4x minus 2. And again, I'm just leaving this factored because what I would like to happen is I would really like this to also factor in the numerator, and one of those factors to divide out with one of the factors on the bottom. That would be really nice. I don't know if it's going to happen, but we can check. All right, does this thing factor? Well, are there two numbers that multiply to get -2 and then added to be -4? No, there's no whole numbers to do that. So this thing is not going to factor. So it looks like this is actually the end of the road for this one. They won't, necessarily factor at the end, but sometimes they might. But that one's done. This one doesn't factor. This is prime. So we'll just leave it like that. Again, if you wanted to, you could write this as x squared minus x minus 2. That would be okay, but I don't know. I like leaving them factored because factoring is difficult. So why make more work for yourself? All right, so let's go back and do addition. So instead of subtraction, let's do addition. Addition is exactly the same process. The only thing that's going to change is this right here. Because for addition, you have to find the common denominators. So there's no need for us to go back and do it all again. It's going to be the exact same common denominator. The only thing that's going to change is right here whenever we're doing the addition. We're going to do addition instead of subtraction. All right, so you can save yourself some work if you're doing like all four of the operations. So now we're going to get x squared minus 2x. Now it's going to be plus 2x and then plus 2 because the positive doesn't change the 2 here. All right, so now this one, the middle two terms are going to go away, and I get x squared plus 2. And then we have to ask ourselves, does the numerator factor? Well, x squared plus 2 doesn't factor. That's prime. There's nothing that multiplies to get positive 2 and adds to get 0. So in that case, we're done. So that would be the addition. So you can see there's not, too much to these. The algebra, it can get a little tricky sometimes, but the rules are no different than any of the other fraction rules that we've already been dealing with. Let me show you one more that's a little different. Just so you don't do extra work. Check out something like this. All right, when you go to add this, again, you need to get a common denominator. But the common denominator here is actually smaller than you think. You don't actually have to multiply these two together. Like you could go over and do this, and that could be a common denominator. Like you could just multiply the denominators together, but it's not the least common denominator. You can actually save yourself some work if you realize that this factor actually already exists in this denominator. Let me show you what I mean. Another reason that factoring early can save you some work. Well, this is a difference of squares. X squared minus 4 factors to x plus 2, x minus 2, difference of two squares. Now if you notice, the x minus 2 already exists in both of these denominators. So I actually don't need to multiply both of these together. I really just need to modify this denominator, and I'll be good to go. Let me show you what I mean. Let's say you had something like this, 1 over 6 plus 2/3. Well, if you want to add these two fractions together, you actually don't need to modify this one. You can just modify the 2 over 3 because 6 is a multiple of 3. So that means that I can put in another, I can just multiply this by 2 and turn it into 6. Another way to think about it is that 6 is really 2 times 3, right? That's the factorization of 6. So if I also had a 2 in here, then these would actually be the same. All right, so that's why if I multiply this by 2 over 2, now I've got common denominators and I can add them together. You don't have to actually multiply 6 times 3 and get 18. That is a common denominator, but it's not the least common denominator. So this is the exact same thing that's going on right here. I have x minus 2 here, and x minus 2 is one of the factors of this denominator. So all I have to do is I need to get the other factor in there. The other factor is x plus 2. So if I could get an x plus 2 right here, I'm in business. Well, if I multiply the bottom times x plus 2, then I can just multiply the top times x plus 2 as well. And now I should have common denominators. And that means that I didn't have to do anything with this fraction on the left. The reason that's important is because if you just multiply these two together like we did before, you'll get an answer, but you're going to have to do some simplification on the back end. It means that you're going to have to do more work on the back end. So if you kind of pay attention to what's going on, you'll save yourself some work. All right, so let's see what this one is going to be. I'm actually going to go ahead and multiply this out. So -1 plus x squared plus 2x, again, because I want to see if this becomes a factorable quadratic, because maybe something will simplify. Let's see, this is really x squared plus 2x minus 1. So actually that is not going to be a factorable. If it was 1 times 1, if it was a positive 1, then that would be okay. That would get me that would make this factorable, but the only way to get 1 is to do 1 times -1, and that doesn't give me a 2x when I add them together. So this is actually done. All right, but I wanted to show you that trick that if you pay attention, you might save yourself some work. Don't just automatically multiply those denominators together. You have to use like all of your math knowledge and kind of put it all together and be looking for things like that. Sometimes going a little slow at the very beginning, thinking things through, is going to save you a lot of time towards the end. I guess I could show you what would happen if you actually did multiply